In this video, we're building something very interesting. We're building a Slack bot that can upload files on a Slack channel, right? So the prerequisites are that you need to have a Slack account, obviously, and you need to be the admin of a workspace, basically on Slack. And then you have to come to api.slack.com/apps. Now, if you have built Slack bots before, and you just want to know about how to upload files, then you can skip the part where I'll show on how to get your bot token and your app token, and you can skip directly to the part where we start working with Golang, or otherwise you can stick around and see how we can get the bot token, right? So we are on api.slack.com/apps. We'll create new app from scratch. I'll call it the file bot, and the workspace is Multech. Create app. Now I need socket to be enabled, so I'll click on socket mode, the third option. I'll enable it, and I'll call this token the socket token generate. So it has generated a token for me, and I don't need this token for this video. I just need the bot token in this video. So what we'll do now is we'll actually go to event subscriptions, and we'll just enable it as well, even though we won't be using events in this video, but we'll just enable it anyways. And then we'll go to our OAuth and permissions. All right, so let's give it some scopes. So obviously we need to be able to read messages. So I'll just say chat write and channels read, and then I need files read and files write, and I'll also say I am read and I am write. Now, if you've watched my other videos on how to build Slack bots, the other videos, then you know that I always recommend going for more scopes than you need, because a lot of the errors on Stack Overflow around Slack bots have been caused because of authorization, authentication, and permissions issues, right? And they all revolve around the scopes. So it's always good to have more scopes than you think you would need, because sometimes the Slack bots don't even give you errors. So that can be very frustrating sometimes, right? So we'll have remote files read and remote files share and write. Also, I'll take those as well. So remote files, sorry, not reminders write, but remote files. The remote files write and share. Okay. Now most of these we may not even use, but we are still, like I said, we're still keeping them. So we have all these scopes, and it might so happen that we might need to add more depending on if our bot is able to perform the actions that we're expecting it to perform. So it's asking me for some permissions. I'll allow it. Okay, and now you have your Slack bot token. I won't copy it right now, but I'll come back for it. All right, and the other thing that you would need is your Slack channel ID on which you would interact with your file bot, and I'll show you that as well. All right, so now what we'll do is we'll head over to our PowerShell, or you could be on your Mac terminal or Ubuntu terminal. Doesn't matter, the commands will be the same. All right, so I'm in the folder where I keep most of my Golang code, and what I'll do here is I'll create a directory called Slack file bot. All right, and I'll cd into Slack file bot, and I'll go mod init and Slack file bot. This is my absolute link. If you're very new to Golang, this is your absolute link with the help of which you'll be able to refer other files in your project. In this particular project, we are going to have only one file, main.go. But if this was a much larger project, then we would have had to write multiple files. And GitHub.com, because once you upload your project to GitHub, you might want to use it as a package in your other projects, right? So it's always a good practice to have your absolute link set up like this. So this is a good practice. We'll go mod init, and it has created our go mod file. So if you ls, you'll be able to see your go mod file, right? And then you need an external package to be able to work with Slack. So we are going to import that. Now, if you're from a JavaScript background, you would recognize this as your npm init, and you would recognize this as your npm install. So now we are just installing an external package. So we'll call it github.com/slack/go/Slack. Right. So this person, just like us, this person had given github.com link, so that now we're able to access his library very easily into our project. So we'll get that. So it has hopefully added the Slack Go // package, and what we'll do is, just to be sure, we'll also run go mod tidy and says all match no packages, no issues, everything works perfectly. And now what we'll do is we'll open up our code editor. So I'm using VS Code. You could be using any other code editor, not a problem. And just another pointer, I'm also using a Golang plugin in my VS Code that helps me write better code. So I'll leave the name of that in the description box below. But even if you just search for extensions, Golang extension, you'll find it. It's not something very rare. Everybody uses it. So we are in our VS Code, and I've opened up a file called main.go, which is what the main file in a Golang program is called, in case you're new to Golang. And the first thing that you write in a Golang program is package main, and then you import some libraries, and then you have something called this func main, right? So these are the things that are the most important in a Golang program. And I know that I'll be needing FMT to print out stuff. So the format package has things that are required to print out stuff to the terminal. Then I know I need the OS package to set and get my environments, and I know that I need the external package that I just installed called Slack Go to help me talk to the Slack APIs, right? Now, Slack Go is a wrapper library that somebody has written around the Slack APIs in Golang, so that we can call the Golang, the Slack APIs as functions rather than as actual APIs. So we don't have to make network requests to the Slack API because somebody has already written wrapper functions around it, and we just have to call those functions using this library, right? So that makes our job extremely easy. And then you can create a variable called API, and it'll have slack.new. So we're using this package now, Slack, and we're creating a new connection. We're calling it, and here we'll get something from our environment, and it'll basically be our Slack.token. Now, ideally, you would have an environment file, right? Or if you're in production environment, you would have the environment set up to have these variables. But since we don't have it set up, what we'll do is we'll actually set our environment right now using the set env. You don't have to do it. You can directly pass your bot token here, but I do this because this makes the code very extensible, and you can extend it later on if you in case you want to go to production. Like I said, we don't want to go to production right now, but if you wanted to, you could, because we're keeping everything very modular, right? So here we'll put a bot token, and also one more thing that I need, like I said, is the channel ID on which the bot will be able to upload the file. Okay. So here I'll have something called as channel and this will be my channel basically. So I'll say string and os.get environment. Inside that we'll have our channel ID. All right. And then I'll have my file. So I'll say file arr string. And here I'll put the name of my file, whatever I want it to be. So now let's go back to our Google Chrome and get our Slack bot token and channel IDs. So Slack bot tokens. This is my bot token, so I'll copy it and I'll paste it here. Okay. And now we'll have our channel ID, and I need to get to my channel ID. So this, I wanted to post it out also on the general channel. So I'll right click on the general channels. I'll say open channel details. Then towards the end, you'll find the channel ID, which is this. Okay. And then I'll go back here and I'll paste it here. Make sense? So now we have set our environment for a Slack bot token and Slack and channel ID. And we sorry, there was FMT here. Yeah, and then we have our variables API, channel, and file, which have the API connection with Slack, and then the channel, and then the file that we'll be sending out, the uploading basically. And now we'll create a for loop. So right now we have only we'll have only one file here, but we could have multiple files, right? So we have to go over all of the files that exist in this variable, in this slice, right? So in this slice, all the files that are there, we'll say I++ and say params slack.file upload parameters. So this is a function that Slack gives us, and it will have two parameters. Okay, and we'll take that into our own variable called params. So the two parameters are channels, where I'll pass the channel in which I want to upload the file, and I'll pass the file itself, which will in this case be file arr I, right? Because we are looping over file arr, which for the sake of this video will have only one file, but you could have multiple files here, like hundreds of files, and then you could loop over them, and then you could send them here. All right, we'll put a comma here because it's giving me some formatting error. So I'll say API dot upload file with the params. All right, so I have my params set here with channel and file, and I'm going to call the function called upload file in my connection, the Slack API, right? And I'm going to take that into a variable called file, or it's going to return an error to me, and so I'll check for the error. So if error not equal to nil, that means there is an error. I'll print out fmt.printf. I'll say %s new line comma error. All right, and we'll say return, and then we'll print out the name and URL of the file. So we'll say name %s URL %s new line comma file dot name with capital N and file dot URL. Okay. So this is a very short, simple program, and even though I've added Slack, I don't know why it's giving me issues. I don't know why there's a squiggly line and shows one error, even though I had actually got my imported the package. So this looks a bit off to me. But yeah, everything else in the program looks okay to me. Let me just go through it again so that we're able to minimize the errors. So there's the channel ID and Slack.new Slack string. Oh yeah, so here we have to just pass the file. So you can copy any file that you want, and I'm going to just copy and paste a file called zipl .pdf. All right, so I'm going to pass here zipl.pdf. But you could have any file out there. And after that, everything else looks pretty all right to me. So I don't know why there's a squiggly line here, even though I've installed the package. What I'll do is I'll again run go get github.com/go/slack. So I'll again add it, and now hopefully the error should go. I'm not sure. Yeah, now it's gone. Weird, right? Anyways, so let's run our code. Let's build our code at least to see if there are any errors. In runtime, there are no errors. So we'll say go run main.go, and at the same time we have to keep our Slack channel open, right? So here in the general channel is where I'm expecting the file to come up, right? So I'll say go run main.go, and let me head over to my Slack channel and see if the file comes here. I don't see the file yet. It says not in channel. So this looks like an error to me. And I'm pretty sure it has something to do with the permission. So let me go over to my Slack terminal and Slack dashboard and see what the issue. So back in my Slack dashboard or my channel, I think the issue could be that the file bot is not a part of the channel, right? So what I'll do is I'll try mentioning file bot. And so it says want to add this person instead, isn't in general yet. So I'll say add to channel. So file bot was added by Akhil Sharma. And now what we'll do is we'll run our code again and see what happens. And let's go back. See, it was able to add the file. It was able to upload the file. So works perfectly. So you'll have to add your file bot to the channel before it can start pushing files to this channel, right? And if you see this error, it's not very helpful, right? It says not in channel. I mean, what the hell does that mean? And I've had so many errors in the past. Like I've built more than 50 Slack bots. Like they're on production. You can get them on the App Store, the Slack App Store marketplace. And then the thing is, it's so frustrating to build a Slack bot because most of the time the errors are around, like I told you, the scopes, right? And because you're trying to do something and you don't have that particular scope selected, and then it won't even give you the right error. It'll just say you don't have the authorization or you don't have the permission, something like that, but it won't tell you what permission you don't have. So it can get really confusing. So just make sure you add more scopes than you need, and whatever scopes you think you might need, you can obviously add them. And don't be shy. I mean, just add as many scopes as possible. Just add all of them, probably. It's not like you're going to share your tokens with anybody else, right? Like delete. So for example, I just made this test app. I'll just delete this bot after the video is over. And now, if you're going into production, obviously, if you're launching a Slack bot to the marketplace, then obviously you need to think about what are the exact scopes that you need, and you can remove the ones that you don't need to make it more secure. But otherwise, while testing it, while learning, go ahead and do whatever you want, right?
In this video, we're doing something really interesting. We're building an email verifier tool. So if you search for email verifier tool on Google, you get all these different options, right? Hunter.io, Snov.io, Zero Bounce, Never Bounce. And all these tools, like let's say if you open up Snov.io and if you open up email address verifier, all these tools are quite expensive, and some of them even say that validate check in real time, right? They try to sound really fancy, but what's happening here is really straightforward. There's nothing fancy happening there. Only in some tools, like let's say Hunter.io, they use a little bit of machine learning here and there to determine basically to make the tool even better and more enhanced. But otherwise, most of them are just using very simple tools to create an email verifier tool. So if you wanted to, you could simply take this program that we'll build right now, and you can just launch your own email verifier tool if you want to. I mean, completely optional. All right. So we'll use Golang, nothing fancy. We won't have bulk verification ability right now in this program. It's very simple. You can extend the functionality of this program to include bulk checking as well. And in the future, a few weeks from now, I'll actually build a complete, like a complete solution for email verification. All right, so this is just a precursor. This is a very simple program that we're building right now. But a few weeks from now, I'll build a complete project around it. All right, where you can also do bulk checking, and there'll be a few more checks. Right now, we're doing a couple of checks, but there'll be a few more checks. All right, so let me show you how the program is going to work. I'm now in my terminal, and what I'll do is I'll start the program. And mind you, this program is super simple, so it won't take us more than 20-25 minutes to actually build this whole thing, right? It's very, very straightforward. So if you go run main.go, it shows you these options. It says that when you enter a domain name right now, it'll give you the domain name's name, and it'll check for MX records, SPF records, if it has any SPF records. If it does, then it'll give you the SPF records. If it has any DMARC records, then it'll give you the DMARC records, all right? And by checking these, then we'll know if the domain is at least right from which that email ID has come, or to which you have to send the emails to, right? You'll just check the domain if it even has any MX records. So that's like the first stage, the first check of any email looking up, or any email verification, that checking if that domain name even has an MX record, an SPF record, or a DMARC record, right? So that you can know at least, there are MX servers set up there, a mail server set up there. All right. So here, let's say you write MailChimp.com. So this is like a irony, because these guys help people send emails, and we're building a tool using their website to check if they have any valid, email records. So let's enter that. It'll take a while, because MailChimp has done a lot of clever things to, not respond straight in a straightforward manner. So it'll say that the request has timed out, right? It says this operation returned because the timeout period expired, but it'll still give you the right records. It'll give you MailChimp.com, which is the domain. Does it have MX record? It says yes, true, it does. Does it have SPF records? False. So that means SPF records, you can see there's a blank here. That means since there's no SPF records, it won't return the SPF records, obviously. Does it have DMARC? It'll say true. And DMARC records, these are the DMARC records, all right? So now you know that MailChimp.com is a valid email. People, it's like emails have been set up on this record, and now you can start looking for the names of the people and then actually finding email addresses of those people if you wanted to, right? Like I said, a few weeks down the line, we'll build the entire product. Right now, we're just building like a, just telling people if the email is real or not. Just like something like, this tool out here called Email Hippo. You write something like, akhil@mailchimp.com. And the first thing it's going to check is what we just checked right now. Does it have MX records, SPF records, or DMARC records? If it doesn't, it'll just say that this email address is not valid. Obviously, because the domain itself is not valid, right? Domain itself does not have any MX records set up. But here in this case, it'll say true, because in our case also it returned true. So I'm not sure if this is, so it's saying the result is bad because yes, the email address does not exist, but probably it's saying that this exists, but this email on this person on this domain does not exist, something like that, right? So anyways, you get the picture of what we're building, and now let's start building it. Like I said, there's no external library used here. We're just using like the basic Golang packages that you get. So if you know even basic Golang, if you just completed the Golang tour, even if you don't know that actually, you can still complete this project. So this is like a simple like a beginner level project. So feel free to follow along with me. All right. Now, since this is a beginner level project, I won't explain a lot of things. There's not much to explain anyways. I won't explain a lot of things. Feel free to code along with me. If you don't understand anything, look it up on the internet or put it in the comments below. I'm always there to help you out, right? But it'll be really simple, right? So there's nothing complicated here. We're not using Go routines. We're not using channels. We're not using even structs. We're not using interfaces, nothing like that. It's just like plain simple Golang. All right, so let's get started. What I now want you to do is open up your new terminal and traverse to the path where you usually keep your Golang code and create a new directory. Let's say like email checker tool. CD into it and open up using your favorite code editor. In my case, it's VS Code. And here, there's not much in this project, right? It's just main.go. So you'll start with package main. You'll import some things. Obviously, we'll talk about them in a while. And then there's your func main, right? The most important function in any Golang program. Func main basically calls another program called func check domain. All right. And this function just takes in a domain. So essentially all you're entering that you just saw in the demo, all you're entering is the domain name, right? So that domain name basically gets parsed from our terminal using func main, something we'll write in our func main. We'll parse it and we'll just push it or send it to our check domain function, which will do all the magic. All right. The packages that I need here, I need Bufio, the buffer package to be able to parse whatever I put in the terminal. I need FMT to print out stuff, log as well, need a net package to make those requests, OS and strings. Okay. Once we'll use these packages, it'll make more sense to you why we're using it. So firstly, you'll create a variable called scanner, and you'll use the buff.io package. And there's a function called new scanner that you'll use. Okay. And here you'll say printf. And the things that we're printing out when the program started will be basically domain has mx has SPF. And if it has SPF, then it'll show you the SPF records. Then we'll check it has demarc. And then we'll check for demarc record. Okay. So if you remember, when we started the program, it just showed us these things so that we come to know in the order in which the information will be shown to us. Okay. So it's exactly the same thing. And now for you to scan the information, you'll use scanner.scan function. And you'll, so let's say if there are multiple items to be scanned, now I know I said that there's no bulk uploading, as in bulk checking, but you can check like a few, emails. But when I say bulk checking, I mean like uploading big CSVs of thousands of records and then checking them in one go, right? That's what we don't have. But like multiple checking is there, all right? I hope that makes sense. So you have scanner.text. So whatever was typed by you in the PowerShell or in the terminal is now basically sent to the check domain function one by one. So multiple domains, if you want to, or just a single domain mostly. I have tested only on single domain, so please, if there are problems working with multiple domains, then it's only because I've not tested it. I've just tested it with single domain. So start the program and just put a single domain like mailchimp.com, like I showed you in the demo. So it just works perfectly fine for that. I've tested only for that. And then we have, like I said, this is not a production level software, right? I said like you can put it on your website as a small, simple, free email checker tool, but don't like charge people for it because you don't have the complete architecture required for it to be a complete production software, right? I hope that's clear. Because I get strange comments sometimes, so that's why I just clarify all these things. So to log out the error, now if there's an error, obviously, then we're just logging out the error. So the error is could not read from input, comma, error. So if you notice, all that we have done in the func main is just pick up or scan the user's input from the terminal, all right, the domain name that you've put. And if it's not able to scan it properly, whatever domain name that you put is going to say could not read from input, right? It's going to print out an error. And what we're sending to this check domain function is the text and that whatever you've posted in the terminal. And now the check domain is the part where which is basically the meat of this entire program, because this function will have all the logic required to actually check those records. Okay. So firstly, we'll define some variables. So the first variable will be has mx, has SPF, has demarc. All of these are Boolean. Then we'll have the SPF record. I mean, if it has an SPF record, then we'll show the SPF record, right? Like in our case, when we did a demo with MailChimp, there was this was false, so that's why we didn't have an SPF record. It was blank. And if there's a demarc tool, like we did for MailChimp, we had a demarc tool. We'll have a demarc record here, and it'll be a string. All right. Now all we're doing here basically is using the net package to firstly look up the MX. So the net package already gives you the ability to look up the MX of the domain that you just sent here. Domain is that string that we're passing to this function, all right? And whatever comes back from this function, we capture in a variable called mxRecords. And this function, if there's anything that goes wrong, it will also return an error. And now you're getting these squiggly lines because you've defined all these variables, but you've not used it, right? So what we'll do now is we'll say if error not equal to nil, this error basically we'll handle on this line. So log dot printf error %v, comma, error. And we'll check for length mxRecords greater than 0 as mx is equal to true. So you looked up the mx for the domain using the net package, and there's a function called lookup mx that you get in that net package, and you got the mxRecords, or optionally you must have got the error. So if you got the error, which means error not equal to null, you'll just print out the error. And if you got back the mxRecords, then you'll check if the length of the mxRecords is greater than 0. Obviously if it's greater than 0, that means that that this domain has mxRecords. So we'll set mx is equal to true, has mx is equal to true. Okay, so this has been used. Now comes the txt records, which are your SPF records. Okay, so we'll use net.lookup txt package. So here, I wanted to observe how easy these kind of things are with a language like Golang. If you want to do the same with Node.js, for example, you'll have to use an external npm, right, or something like that. I mean, I'm a Node.js user. I've been using it since many years now. I have built multiple products with Node.js. So I should have nothing against Node.js, but actually I do. So I do have a lot against Node.js, because to do something as simple as this, you have to do a lot. You have to do a lot of bending. In case you know a better way to do this with Node.js, do reply in the comments and do share it with me. I don't know. But with Golang, it's super simple, right? You don't have to install any external package. All these are, the standard Golang packages that you're using right now. And that's insane, right? A language that has so much support out of the box is just killer. That's why, it's the language I use the most right now. So here also you look up the text records, which are basically your SPF records, right? So if similarly you'll check for the error. So if you'll say if error not equal to nil, then you'll do something here. So you'll say log dot printf error %v / and comma error, and then what you'll do is you'll range over these records. So by ranging over, if you're very new to Golang, I basically mean like using a for loop to go over all the values. Okay, so we'll go over the text records, and the right syntax for that is for and record. So this is going to be your iterator, and this is going to be your every single value that you'll have access to with the help of range records. So inside your text records, you'll range over them, and every single value inside that text records, you'll have access to it using this variable called record. And here you could have used the iterator like I or j or something like that. But since we don't want to use it, we'll put a blank character here, because in Golang, you can't just define something and then not use it. Okay, that's why you have to use blank characters. So here we'll use the strings package provided by Golang again by default, and you'll use the record. Record is basically every single value, like I told you, from this text records. Once you range over it, every single value can be accessed using record. So we're passing strings.hasPrefix. In that function, we're passing the record. And we're checking if this it has been represented like this. So usually the SPF records in your text records, right, all your TXT records, in that you want to find or search the SPF1 records, okay, if the way they represent it. So if you go to your, let's say, your GoDaddy or your Namecheap, you'll see that you have these TXT records, and they will look like this. They'll have like a V is equal to SPF1. And so you'll obviously set the SPF has SPF is equal to true. And then you'll also have your SPF record, which will be set equal to the record now. And then you'll just break away from this program. So a few minutes into the program, we've already checked for the MX records and SPF records. All we now need to check for are the DMARC records. Now, to check for the DMARC records, we will again use the net dot look up txt, but we'll check for DMARC plus the domain. Domain again is that same variable that was passed into this function. And here we'll say DMARC records, comma, error. So whatever's coming back from this function, the function is lookup text that you have already used. In the net package, you're passing domain plus the DMARC record to check if you're looking up the DMARC records using the same function. And whatever you're getting back, you're either getting an error or you're getting the DMARC records. So we'll check for the error. So if error not equal to nil, say log.printf and we'll print out the error. And otherwise, we'll range over the DMARC records. To do that, you have to follow the same kind of a syntax. And here you have to say if strings dot has prefix record comma v is equal to DMARC 1. So you're following the same method process. There's no change here. All right, same process. And here instead of record SPF1, we are saying DMARC 1. And if it does, then we'll say has DMARC has become equal to 2, true. And DMARC record value is equal to the record value. And then you break away. And at the end, you'll just print out all the results. Right, so you have to use the printf method. And to print out the values, so you'll say, I'll put the percentages later on, the percentage V's later on. The values that I want to print out to the terminal are domain has MX has SPF. I have this reference, right? Domain has MX has SPF, all these. This was just text, and here we're actually pushing out, like printing out those values, but in the same order. SPF record, comma, has DMARC, comma, DMARC record. So how many V's do we have to put here? 1, 2, 3, 4, 5, 6. So we'll say percentage V, comma, percentage V, comma, percentage V, comma, percentage V, comma, percentage V. So it's 5 now, and then the last one is 6. So 6 percentage V, and this whole function is complete. Now all we have to do is test this function, and we know that we'll get some errors, and then we have to solve those errors, and everything will work. To actually find the errors and see if it's working, we'll have to actually run it on our terminal. So here I'll say go run main.go. And as you can see, it's working. So I'm surprised that there are no errors. So it's working, everything's working fine. Let's try entering MailChimp.com again. I've tried it with many of the websites like MailChimp and SendGrid, Sendinblue, all of those main big email sending tools. You can try more domain here. Actually, any domain you try, you can try it here. So this, as you know, the request will time out after a while, and then we'll get those results. And if it doesn't give you any results, then That means there's some error with our program, but I'm hoping it'll give some output. Yeah, so we have got that output that timeout period expired, and then you get your .com true, false, true, and you get the demarked records. Okay, so I hope you enjoyed this program, this project. This is a very small, simple project, but obviously it's a nice flex. You can flex in front of your friends. You built like an email verifier tool, all right? In this video, we're building a very simple AWS Lambda function using Golang. So AWS Lambda is a serverless technology where basically you create functions and you host them on the cloud, and you only pay for usage. So whenever only somebody uses your functions, only then you pay for them. So there are a lot of use cases for serverless. It's a growing technology. Everybody's shifting their entire stacks to serverless these days. And I found it to be a very good fit for, let's say, if you're building an MVP, because you don't know if there will be traffic coming to that product, right? It's not a proven product, so you don't know if there's any traffic that's going to come to it. So that kind of, at least ensures that you don't have to keep paying for your servers, right? You only pay when somebody uses your product. And a lot of people use it throughout the development lifecycle, like throughout the product lifecycle, right? Like right from the POC to the MVP to actually scaling, because scaling in serverless using Lambdas is very easy, because you actually don't have to write any like huge configs, right? You don't have to create servers. Everything is done automatically for you on the cloud. So it's a completely fully managed service. You don't have to do a lot, basically, right? So you just have to focus on the business logic, which is just creating your functions, and everything else is taken care of by the cloud. It's also very cheap to use because you're not paying for the servers, right? You're only paying when somebody uses your programs or functions. So if you're building an API that's going to be, exposed to the world, and the world is going to, and there are many more developers who are using your API, then AWS Lambda is again a very good use case for that. Now, there are a few drawbacks to using AWS Lambda. For example, there's cold start, wherein if somebody's using your Lambda and basically the Lambda takes a while to start, so that's called as a cold start because there's a slight delay there sometimes. So they've tried to reduce it, but it's still there. I feel cold start problem is still there. So drawbacks will always be there, but it's a very good technology. Everybody's kind of adopting it. Everybody's using it. It's widely used, very popular. It's important, right? So it's important to learn. And so that's why I wanted to create this video, which is the basic, creating a very basic Golang function, and then deploying it as a Lambda function on AWS. Now, you will find a lot of videos where people use the GUI, the AWS GUI, to deploy a Lambda function. But in this case, I'll be using AWS CLI because I did not find many tutorials. Actually, I didn't find any tutorial on YouTube which uses AWS CLI to deploy a Golang Lambda function. All right, so that's why I thought let me create one, because I don't use the AWS GUI a lot. I use the AWS CLI. All right. So now there are two prerequisites to this video. One is that you should know the very basics of Golang. And actually, even if you don't know the very basics of Golang, I'll explain line by line the whole program to you. It's a very small program, so that's probably not a big prerequisite. The second one is important. The second one is that you should have AWS CLI installed and configured on your laptop or on your whatever desktop machine, whatever that you're using, right? So that's kind of important. You need to have AWS CLI installed because, like I said, I'll be showing you the AWS CLI approach, not the AWS GUI approach, because that's something that many people have covered already, right? AWS CLI, I find it to be quicker, faster, and you don't have to leave your window. And if you're a nerd like me, obviously you like working on your terminal, you don't want to use GUI, right? Now, now the next video that I'll create after this will be a complete serverless stack that we'll be creating, right? We'll create APIs that can be exposed to the public, and those we'll create using Lambda, DynamoDB, and API Gateway. That's a complete serverless stack. That's in the video that's coming up soon. In that case, since I don't want to create very complex config files, I'll use the AWS GUI to deploy the Lambda functions and to actually configure my API Gateway. But only because the config files are going to be very, very complex, like YAML files. So that's why I want to do it on the GUI and not write those YAML files. So that's why here, because it's kind of easy, I'll just use my CLI. All right. I hope that makes sense. And even in the upcoming video, I'll create config files if you want me to. I'll show you how to do that. But I kind of prefer going the GUI route in a project that's a little more complicated. All right. That's just my personal preference. So having said that, we'll have to get started now. A lot of talking has happened. So this is my terminal, and you don't necessarily need to keep the project in a folder where your Golang is installed, right? Like GoPath and GoRoot could be somewhere else. You can have the project anywhere else, doesn't matter, because we'll be using the, like we always do, right? The Golang 1.12, the format that came after Golang 1.12, which was basically, using gomod init, right? Which can initialize your gomod file anywhere. Doesn't have to be in the root or path. But usually also I prefer keeping it in the Go root and Go path, because I've been a Golang developer for a very long time. So that's why I prefer keeping it there, but you can keep it anywhere, right? So because I'm saying this because I get a lot of questions on YouTube saying that, hey, my Go path is, configured like this, but I'm keeping my project like this. Is that okay? And do I need to keep my project in Go root? So the answer to that is you don't have to do all of that. You can, keep it anywhere. I keep my projects in the Go root most of the times, because that's how I've been doing it since a very long time, before Golang 1.12 was there, right? So you don't have to do it. I mean, the Go mod init takes care of everything. You don't have to do anything. So let's create a new directory. So we'll say lambda YT example. Okay. And so we'll cd into it, lambda YT example. And here we'll just say go mod init, and to initialize, I'll say github.com/akhil/go lambda function 3. Okay, because I've created many lambda functions on my AWS account, so I just need to be sure that this is a different lambda function altogether. All right, now this is my project file, project name. And I don't have to keep the same name as my lambda function that I declare in my AWS, but I'm just for consistency's sake, that's what I'm going to do. I'm going to have this name, the same exact name, in my AWS lambda console as well when I declare the function. All right. So there are two parts to this video, the video will be one, but I'm dividing it in two parts, like contextually. The first part where I'll be building the Golang function with you, which will be a simple function, and the second part where we'll deploy that. We'll do the AWS configuration parts. The second part is slightly where you need to pay more attention, because that's where all the magic happens. And the first part is just creating the Golang file. So if you want to go quickly through the first part, not a problem. Just make sure that you slow down in the second part where I actually show you how to deploy the Golang functions, because there are a lot of caveats there, a lot of different working parts there, and one small mistake will completely mess up your entire deployment. All right, so now what we'll do is we'll open up our code editor. I'm using VS Code. You could be using anything else, and let me bring VS Code here. All right, and here all I have to do is I just have to create a main.go file, and we'll be just using one dependency in this entire project. That is it. All right. So this program is going to be short, and we're going to code a bit quickly. In case you're new to Golang, main.go file is basically the entry point into the project. And in this program, since it's a very small and simple program, we have only one file, which is the main.go file, right? And the way main.go file starts with is you write package main on top, and you import a couple of packages here, other packages that you want to use in this file. And you have the most important function from where basically the control of this program starts, which is the func main, right? And sorry, I need two packages. One is called the FMT package, and the other is called the Lambda package. So I'll say AWS/AWS dash lambda-go/lambda. All right, and we need the lambda package obviously because we're creating a lambda function. And FMT basically helps us, if you're new to Golang again, FMT basically helps us with some basic functions like printing and all, right? So Golang is very modular. Even printing is not there in Golang, so you have to import a package, which is a native package, by the way, for printing stuff, right? And all we're going to say here is we're going to say lambda.start, and in that, so lambda is basically this package that we have imported, and start is a function that that package gives us. And here we'll say handle lambda event, which is a function that we are passing to this function. All right. So this means that handle lambda event is a function that we'll have to create here. So we'll create that function handle lambda event, and it accepts something and it returns something, right? So what does it accept? It accepts an event. So we'll say my event, and it returns a response. It can also return an error if there's an error. And here we'll just basically return response, right? Now let's define what response and event are. So we'll say type this my event and my response are two things that we'll define here. So my event is basically a struct. Similarly with my response is again a struct. So in case you're new to Golang, structs are basically your own data types that you can create, which are a combination of multiple different data types. All right. So if I'm creating a data type called my event, it's going to have name, which is a string, and JSON, what is your name. By the way, I have more than 100 Golang videos on my channel. So if in case you're planning to learn Golang, do take a look. There are a lot of different type of projects, and the way I teach Golang is that I basically show you how to build projects and not just teach the basics, right? So it has just two things, name and age. All right, event. So string, which is basically what is your name, and int, which is how old are you, and it's going to store an integer, which will be the age out here. All right, and your my response struct will just have message, which will be a string, and it'll be JSON and answer. Okay, in case you're wondering why we have to define JSON like that, we're just defining that for the purpose of Golang. Golang understands string and int. It doesn't understand JSON, right? But what we're going to send when we invoke our Lambda function, we're going to send JSONs to it, right? So that's why we have defined how it's going to look in JSON. So here in my response, you already know that my response consists of message. So we will say message fmt dot sprintf is a function that helps you to format your strings, and you'll say %s is %d years old. Now you have to substitute %s and d, so you'll pass those values here. So you'll say event dot name comma event dot age. So event will have the name, which let's say John, and how old are you will be the age. So all you get in the response when we invoke this Lambda function is we get John, which is %s, %string, right? The name is 32 years old, or whatever you want to send here. And here for the error, you would want to pass nil, because it passes response and error. So for the error, we are saying send nil for now. And this is what the entire program is about. I mean, that's it, 24 lines. Even if you remove these spaces, it becomes even less, but I won't remove that space. So it becomes like, let's say 22 lines. That's it. That's all we're going to test right now, right? So that you basically come to know what Lambda is, how it works. And then once you're comfortable with it, then we'll build the entire serverless stack project. All right. So now is a good time to go back to our terminal, and we'll start doing some operations here. Now I'm obviously assuming that we already have AWS CLI set up, right? And now there are three things that you want to do in the beginning itself. Now these three commands that I'll show you here are from the official Lambda deployment documentation. So if you open the Lambda documentation for AWS deployment documentation, you'll see these things, these exact same steps, right? So this is nothing new, and I'll copy and paste these in the description box below as well, so that you can copy and paste them. And also and you can easily find them on the internet, so you don't have to worry too much about it. The first command that we're going to paste here is basically a command that creates a role name, right, called lambda x. which will have the right role policy documents, and that's what will basically allow you to access Lambda on your AWS account. All right. So when I press enter, in my case, it should give me an error saying that this has already been set up for my account. Ideally, that's what it should. Yeah. So it says an error occurred. It already exists, right? Now the second thing that you need to do is you need to go back to your function here, and you need to create a file called trustpolicy.json, and this is something that Lambda requires, right, to be able to trust the program that you've created. So I'm going to copy and paste some JSON code here, and I'll share this code with you in the description box as well. So that's all you have to do. Now these two steps, like I said, are directly from the Lambda documentation. Now there's another third command that you need to now put in your terminal. I'm not sure why it's not coming. Just one second. Yeah. So this is basically pointing to the trustpolicy.json document, saying that this is the role policy document here. All right. So in this case also it should give me an error because I've already done it. All right. It already exists. And now there's another command. So there are 4 commands till now, right? So this 4th command also is very similar. There's some issue with copying and pasting that I'm facing right now. So all that these functions are doing are helping you to basically set up your policies and roles and permission, all of those things. All right. So now that the basic work is done, and now Golang won't basically, AWS won't stop you from uploading and deploying your Lambda function now, because you have already the trust policy document. So all you have to do now is you have to build your main.go file. So you'll say go build main.go. So it says that I have not installed this package. So I'll say go mod tidy first. This is what's really great about Golang, because it doesn't let you make any mistakes, right? So you'll say go build main.go. So it's built the. So as you can see, this main, right? This is the executable file which we want to send to Lambda. Now, before you send or upload anything to Lambda, you need to have that file as a zip file. So you'll say zip function.zip, and you're going to zip the main project, right? So now if I ls, it'll have this function.zip, which is the name of the file, right? So we'll call zip. Now it's possible that your particular Ubuntu terminal doesn't have this function called zip, right? So if you're on Ubuntu, it's very easy. I think it's just sudo apt install zip. And similarly, if you're on PowerShell or on PowerShell, it's also easy. I think you can use the Choco installer, package installer. And on Mac, you can use Homebrew to install zip. And it's straightforward, as in it just takes your main executable file and zips into a file called function.zip, and that's the one that you want to upload. Now comes the most important function, right? So I'll paste this function here, and then we'll have to change the name of the function. I'm not sure why I'm not able to copy and paste it easily. There's some issue. Wait, actually I'll just bring out my notepad because I need to make changes to that program, right? So this is the entire function that we want to basically, the entire command that we want to run right now. And all it does is it basically creates a Lambda function, and it gives the function a name. And what we're saying is that this is the zip file, function.zip, and handler is basically main. Inside that zip file is main executable file. And the runtime that you need is Golang 1.x. All right. And here the name of my function is actually something else. So that's what I need to just verify. Go lambda function 3. That's the name of my function. So I'll say go lambda function 3. All right. So I'll just copy and paste this command here, and I'll run it. Everything seems fine right now. One more thing that I forgot to mention is that this is my particular Amazon account ID. You need to replace this number with your account ID. All right. Otherwise, this program won't work. It's taking a while because it has to create that lambda function. Also has to upload that function.zip file. So it'll take a while. And then the last command that we'll be running will basically be for invoking that function. So in the meantime, while this function is running, I'll just copy and paste that other function here that we'll use to invoke. So as you can see, what's happening here is it's basically this function, this command will invoke your lambda function. In my case, the lambda function is called go lambda function 3, right? And so this part, this I found from Stack Overflow. This is not in the documentation. If you don't do this and you pass JSON in the payload, because you have to pass JSON in the payload, right? We have to pass JSON in the payload because that's how our request and response will work. It'll be, what is your name? How old are you? Right? And sorry, let me just make this full screen. Yeah. So what is your name? Is Jim, and how old are you? Is 33, right? That's how our function is structured in case you don't remember. This is, see, what is your name and how old are you? And the answers for that is Jim and 33. And whatever happens, like let's say even if there's an error or the response, will be formed in a file called output.txt. All right. And if you don't, so this is something that I didn't find in the Lambda documentation. This I had to find from Stack Overflow, because when I was passing my JSON, I was getting some errors. So just make sure you write this little, text here. And so this is your program. Now, if you see here, this has stopped, this is basically deployed and everything seems to be fine. And it's giving you the latest version. So your Lambda is deployed. And now you'll just say Control C. And now you want to just pass the last command. Let's try and invoking it and seeing what happens. Something wrong with my copy and paste. Let me actually start another terminal. I will seed into the directory. It's called Lambda, something like that, right? Sorry, yeah. User cd lambda and YT example. And here, yeah, so this is the exact project that we're in. And here is where I'll just run this command. You don't have to necessarily run this command here inside this project directory, but I'm just doing it because of habit. So again, it'll take a while to invoke. So it took about 4 or 5 seconds to invoke. I say status score 200 and execute latest version, which is called as $latest. Now, how do we know that everything worked fine? Because we need to check for this file called output.txt. So we told our Lambda that you invoke this function, and whatever output that you get by sending this payload into the function, you write that in a file called output.txt. So that's what the file we need to look for. So as you can see, there's a new file called output.txt here. You click on it, and you say that gem is 0 years old, which is wrong because it should have been 33. So that means our program is misfiring, and we need to just check for that now. So we'll just comb through our code quickly and see the issue. The issue seems to be out here because there's no question mark here. So when we're passing this here, right, as a question mark, or just remove this question mark for now. For now, just remove this question mark, because if we remove add a question mark here, we'll have to redeploy this entire function by zipping it, right? So for now, let's just change our invoking function and copying it and pasting it again here, and let's see what happens. So we'll wait for it. It has completed the execution. Now it shows Jim is 33 years old, right? So what's happening here is basically it's matching this completely properly. Like even if there's an extra question mark, it won't read this value, right? So just make sure these both statements, they match. And that's the only error that I got, and everything else seems to be working fine. So that's it. That's your complete Lambda function, and deployed to the cloud. When somebody uses it or you use it, only then you have to pay for that particular usage. Otherwise, everything is perfectly fine. In this video, we are building a very basic lead management system or CRM using Golang and GoFiber. And this is a completely beginner-friendly video. So if you have no hands-on experience with Golang, this is the right video for you to get your feet wet and start working with Golang. Now, I'll be using a very basic database called SQLite. So it won't be very difficult for you to set up or start using, okay? And I won't be using any concepts that throw beginners off with Golang. I won't be using any pointers, difficult advanced struct modeling. I won't be using marshalling and marshalling. I won't be using like channels and go routines. I won't use any of the concepts that the beginners find really difficult to understand. So this is a great project to get started. The only prerequisite is that you should have SQLite installed. Ideally, if you're on Ubuntu, it's very simple. It's very easy to install SQLite. Just one command, I think, apt-get install SQLite. You don't have to do much. So with that out of the way, let's start setting up the project. So I'm in my terminal now, and it doesn't matter how your Go path is set up. We are creating a new project using Go mod. So that'll create the entire package for us and do the package management for us. So we can create this folder or this project anywhere in our computer. Okay. So I'm going to create a new directory, and I'm going to call the project GoFiber CRM. I think basic, and I'm going to cd into it, and I'll also go mod init, and I'll just give my username, and then I'll give the name of the project, GoFiber CRM basic. Now go mod init creates a go.mod file, which is going to basically contain the list of all the dependencies that we'll use in this project. So you open this up I'm opening it up using VS Code. You can use any other code editor. And here I'm using, if you go to your Golang, if you go to your VS Code extensions, the first few extensions that come up when you type Golang, just install those. Because that'll just make your experience better, in the sense they'll lend the errors and the issues for you by default. And I've already done that. So even if you don't do it, it's completely okay. But if you do it, then you're just able to find those issues much faster and easier. The way we'll structure this program is going to be really simple. We just have a database folder. We'll have our lead folder, and we'll have our main.go file. Now, main.go file is the most important file in your Golang projects. And this is basically the entry into your project. And in your lead, you'll have lead.go file in the lead folder. In your database folder, you'll just have a database.go file. So with main.go, this is how you start the main.go file, right? It's called package main. And the second thing that you usually write are the import statements for the packages that you might want to use. And then the most important function here in the main.go file is usually, or it's actually always, funcmain. So this is how you write funcmain. You just create these two brackets, and then you create these two curly braces inside which you'll actually write the function definition. And since I've already told you that I'll be using Golang Fiber, GoFiber, I'm going to go ahead and install it. So I'll say github.com/GoFiber/Fiber. Now, since we're using this package, whenever you've written down any packages and you want to install them, you just have to run this command called go-mod tidy, and it'll find all the packages that have been defined but not installed yet, and it'll install all these for you. So it'll go ahead and find the model for package and it'll install it automatically. Okay. What you want to do is you want to create some routes. So we'll create some routes. We'll say func setup routes here. And the routes will be simple. They'll be get leads, right? In the CRM, there'll be a create lead. So we'll have app.post new lead. There will be delete leads. So app.delete. There will be delete lead. Okay. And now you've been calling this app, but what is this app exactly? App is basically an instance of your Fiber. So you'll call the Fiber library like this, and you'll say dot new. Okay. And you'll go to the next line. You'll say setup routes, and you're going to pass app into this folder. I meant function, not folder. So into this function, which is set routes, you pass app, which is basically an instance of your Fiber. And by the way, you've seen that this squiggly line has gone away. That means it's done installing the Fiber package for us. Okay. Now, if you're passing app here in this function, that means you have to accept app into this function, right? So this is how you accept it. So you say fiber.app. I know there's a star here and it's a pointer, and I said I'm not going to be using any pointers, but this is just one little exception. Okay, I won't be using it anywhere else, but just to give it reference and to refer to the app that's being passed into this function, we have to use the pointer. So in case you don't know what pointers are, don't worry right now. I'll be creating very basic videos on explaining pointers, but for now you just have to remember that app has been passed into this function, and we just want to use it or call it by reference. Just remember that, call it by reference, as in we don't want to directly use app. And why and how it works and what are pointers, all of that, I'll be explaining in a different video, in a very basic kind of a video. For now, just remember that you just have to put a star here. That is it, right? That's all you have to care about. Anyhow, so you have defined these three different things, but I need one more. Okay, I need one more, and it's called just getting one lead. Dot get and just get lead. So how this is working is that for this new lead, you'll have a route which will help you create a new lead. And for getting all leads, you can have get leads. For getting just one lead using an ID, you can have get lead function. And then delete lead function will be for deleting a particular lead with an ID. Okay. So now you want to have app.listen. This starts off your server at the port 3000. And
and you also want to connect to the database. But what I'll do is I'll just define the database first, and then I'll come here and then start, we'll connect to the database. Now, you want to create a function here called init database. Okay. And you want to go to database.go. And here you want to write package database. We'll import a couple of things. And we'll define a variable. We'll define a variable to be able to connect a connection, or to be able to create a connection with our database. So we'll call it dbcon as a representation or reference to DB database connection. And it's going to be of type gorm.db. Now, Gorm is basically Golang ORM, which helps Golang to interact with the database. Otherwise, you would have had to write all those queries yourself. But here you don't have to, because you get the help of Gorm. And now that also means that you'll have to import Gorm, because Gorm is not is an external library, right? So you'll say github.com/Jinzhou, which is the name of the person who's created Gorm, and then you write Gorm. You'll also get the exact support for the exact database that you're using. So the database that you're using is called SQLite. Inside Gorm, we have something called as dialects, and you get SQLite. So dialects basically means language, right? So inside Gorm, what language do you want to use? So we want to use the SQLite support language, basically, to be able to connect our Golang with SQLite. So what you want to do is you want to put a slash here, and then just copy and paste it here, right? And just run go more tidy again, and you'll get these two packages, and the squiggly line will go away. So always just keep running go more tidy, right? So I just run it some time back, and I got all the packages. So your database.go file is complete. Now we'll come back to our main.go file. Here, what you want to do is the database that you just created, right? The database file that you just created, or the database package that you just created. You want to import it here. So you want to say github.com/akhil/ the name of the project. The name of the project is Go Fiber CRM Basics. So just write that same name here. And /database. This tells Golang that you want to import the database package that you just created here in this folder, and you just want to import that. So once you import that, then you can access the code that you've written there. Okay, so this makes the Golang code modular, in the sense you don't have to keep everything in the same file. You can divide it into different packages, and you can install or import those different packages into your main.go file. And this is how I've imported the database package that I've just created into the main file. All right, now what I want to say is, in my main file, main function, I want to call a function called init database, and I want to start a connection. So we've just defined the DB connection variable, right? So you want to say database, which is your database package, which we are accessing using this database. .db connection, which is the variable that you just created, which is of type gorm.db, remember. So you say database.db connection dot close at the end. Now differ is a statement that you can check out. It's a Golang statement, which basically means that this line that we've just said, that the connection to be closed, will happen at the end when the function has completely run, everything has happened. After that, only this function, this line will run, this command will run, which will close the connection, right? So we're just making sure that after everything is done, after the whole func main has executed, only at the end, when everything is done, just at the end, just before the end of the program, the last line or the last command to run will be this one, database connection close. Anyhow, so this init database function that you have called here and we've defined here, we can now start defining it properly. So first you'll define a variable called error, and you'll say database dot db connection. Just to remind you, database is our folder package that we just created here, database.go package, and db connection is the string that we just created. So we are accessing the database package and the database connection string, just like we did out here. And we'll also have our error, and here we'll say gorm dot open SQLite 3 and comma leads.db. So what's happening here is that you use gorm to open a connection to your SQLite 3 database. The database name specifically is leads.db, and you get that connection in this database.connection, or if it's not connected, you'll get an error. Now with the Golang, what you do is you handle error after every single operation that's taking place. So just as this has happened or taken place, we want to handle the error right here itself. So we'll say if error not equal to nil, you want to panic and say failed to connect database. But if everything went well, then you want to say connection opened to database, and you'll say database.db con.automigrate ampersand lead.delete. I'll explain to you what this is. And at the end, you want to say println database migrated. Okay. Now lead, right? Lead that you see here. You want to define the lead. Now, the reason we're getting squiggly lines here is that FMT is not imported. FMT is the package that helps you to print. Now, Golang is so modular that it doesn't even have the ability to print on its own. So it's there in a package called FMT that you have to import into your program, and then you have to use println. And this keeps Golang really light and fast. So you also want to have yeah, I think this looks good. Yeah, so you want to now we want to talk about lead. And what's lead basically? Lead is going to be this package here that we'll define, right? So firstly, we can define this package. We can say package lead, right? Just like package database we had defined. It's going to have some import statements, and most importantly, it will have a struct. Now we won't have any difficult or any lengthy structs and relationship between those structs and modeling, all of that. We don't have any of that. We just have one struct. Struct is basically a data type that you're creating on your own. So there are some data types that you get with Golang, like string and int, and that's all we're using. We're just using string and int in this video. So you get these kind of data types with Golang, right? String and int. But what if you wanted to create your own data type with a combination of strings and ints? And you can do that with Golang, and it's called struct, right? So struct is your own data type that you're defining out here. And you're saying that lead is of data type struct, and the struct is going to be gorm.model. It's going to have name, company, email. Sorry. Company, email, and phone. So for a lead management system, we'll just have name, company, email, phone. That's it. Phone will be int. Now what I'll do is I'll just create proper spacing between them so that it all just becomes a little more readable. And That's about it actually. So this is how what your lead is going to look like, right? So when you go back to your main.go file, you want to now import that lead, right? So right now, obviously the lead file is not complete, but eventually at some point of time it will be completely complete. But you would want to import the complete lead package into your main.go file because you want to run some operations on it. And so how do you import it? You just do the same thing. This is your main path of the project, right? Your project is github.com /go fiber basics CRM because that's how you had defined it when you was doing go mod in it, right? That's how you initialize the project. And you can always put a slash here and you can say lead, and it'll know, Golang will know that you're talking about this lead package out here. Now, all these functions, right? So get leads, get lead, new lead, delete lead functions. We can either define them inside our main.go file, or we can define that in the lead file and keep our main.go file lean and simple and small. So that's what we're going to do. We're going to keep all those functions in our lead.go file, and we're not going to keep them here. So that means that those functions will be in a lead package, and that's how you refer anything in another package. In a lead package, we'll have these functions: get leads, get lead, new lead, and delete lead. And the way to access them will be like this with the dot notation, lead dot. Okay. Now you want to define the actual route, right? So the route will be slash, we'll keep a version v1 slash lead, right? So if somebody using Postman or using curl hits this route API slash v1 slash lead, then he's going to be able to get all the leads if he uses the get method. If he uses the post method on the same route, he'll be able to post a new lead. And for the get one by ID and delete by ID, it'll be same, but at the end there'll also be that ID of of the lead, particular lead. Cool. This is what you get, right? This is how you set up the routes. Now the program looks complete, right? And we'll head over to our lead.go file now. So it's saying that I don't recognize what gom.model is. It's giving you a squiggly line. That means you have to import the GORM. I think my video had stopped for a while. I've just switched it on back again. Anyhow, so with import, you want to import the GORM, right? So you'll say github.com/jinzoo/GORM. Now you notice that it doesn't give you a squiggly line out here. And that's because Golang already recognizes it because it's already there in your go.mod. Right, jinzoo.com is there. So you don't have to run go mod tidy again. You can just keep this or import this into any file once you have done go mod tidy, once you have imported it in your project, right? So now you'll again get your go fiber. So I'm just going to go to my main and just copy go fiber because I'll be defining the functions to work with those routes. So that's why I need go fiber here again. And similarly, what I need in the database, the SQLite, I'll just copy and paste that also here. All right. And I also need access to the database. So what I'll do is I'll just copy this line and I'll put it here. So soon, in a while, I'll need access to the database, right? The database connection and all, because I have to, for those get all leads and post lead, I'll have to work with the database. So I need access to the database connection. That's why I've imported the database as well. And now I want to define all these functions that I have in my main.go file.
which is basically get leads, get lead, new lead, and delete lead. So let's do that quickly. So first function will be get leads. Second function will be get lead. Just lead. Third function will be new lead. And fourth function will be delete lead. Now they'll accept some things, and then they'll have their own function definition. So just do that for all of these. Now, what are they going to accept, right? They're going to accept C, which is basically your fiber.context, fiber.cdx. In case you have no idea how context works, don't worry. I'll have another video and the basics on explaining context. But this is a very basic concept of Golang, and in case you already know, that's really good. But if you don't know it, just remember that to all these functions that are being driven from these APIs, right? From the APIs, you hit a route and you call a particular function. There you have to pass your context to your fiber, okay? So I'll just give you a very basic idea. What this is doing is that this function now can start to work with the data that's coming from the user. So for example, in my get lead function and my delete function, I'll need to use ID, right? And I can use that, I can find that ID in my C.params. Basically, C will have all the data that's coming from the user. So I'll show it to you with an example, you understand it. So for example, in my func get lead, now I want a particular ID, right? I want a lead of a particular ID. So that means I need to define a variable called ID, and I can now get access to the params that the user is sending. The user is going to say that from the postman or curl that, hey, I want the lead for this particular ID. So that ID, you'll have access to that ID using C.params. So this is why C, which is of type fiber.context, is important. So what we'll do is we'll just copy this and paste it everywhere. Make sense? Now, let's just finish this function off first. So here I'll have a variable called db, which will be of type database.connection. And I'll have a variable called lead, which is of type lead. Now I have the ID that the user has sent to me that's saying that, hey, I want the lead of this ID. And I'm now going to my database to fetch the data for that particular ID. And what I'm saying is that DB, which is my database or DB connection, right, which is the instance of the database session that's going on right now, I will find in it the lead with the particular ID. So I'll say lead with the particular ID is what I need. And we'll say c.json lead. So we are able to also respond using C. The fiber context will also respond. We are able to send the response, right? So we are able to work on the request. We're also able to send the response using C.json, and we'll send the lead in the JSON format, okay? So this kind of saves our effort from marshalling and unmarshalling. Now with the get leads, we'll do the same thing. We'll say db is equal to database.db connection, and we'll define a variable leads, which is of type lead, but it's a slice. Now, when we say get leads, we are basically saying that get all the leads that exist in the database. We're not saying that get a particular lead with a particular ID. We're saying get all the leads in the database. To do that, you need something called as a slice, which is almost like an array. You need a slice of all the leads, right? So lead in this case is the struct that you've defined. And when you say slice of leads, that means that there can be multiple such leads with this particular struct, right?
Or in short, if you're from a JavaScript background, you would understand that it's an array of objects. It's not just an array, it's an array of objects. That's what a slice is. Okay. So you have variable leads and you have the slice of type slice, which is lead. And you'll do the same thing. You'll say db.find. And you can say db.find because db is the instance of the session for the database connection, right? So you'll say db.find and you'll get all the leads and you'll send the response in jc.json. You'll say leads, send all the leads. Similarly, you want to also have code for new lead. And again, you'll start with db is equal to database dot db connection. And you want to define a variable called lead, which is new lead. And if there is equal to c.body parser lead. Headers are equal to nil. C.status 503 dot send error return. Okay, so what's happening here is you get you use body parser that you get in your Fiber, right? In your Fiber package, you get access to body parser. It parses the body of the lead data that the user is sending to you. So the user is using Postman, mostly, Postman or curl, and it's sending you the data for a new lead. Well, this data needs to, checked first. So we'll parse it, we'll do the body parser. And if there's some problem with parsing it, right, it's going to send an error. So this error is 503 that we're sending here. But if everything goes well, we'll just create that lead. So we'll say create ampersand lead c.json. And once you have created that lead in the database, you want to send that lead just to show the user that, hey, this is the lead that was just created in the database right now. And this is how you create a new instance of the lead. Okay. So the new lead function is quite simple. It's just using body parser to go through the data of the lead that the user has just sent, and then checking if there's an error or creating a new lead, and then sending the response with that same lead. I hope that makes sense. Now delete lead. To delete a lead, you need a particular ID, right? Because you want to delete a particular lead. And so you'll say ID is equal to c.params ID. And you'll say database is equal to database.db connection. We will define a new lead of type lead. When you write something like this, right? When you say var lead, right? You've done it here also. Well, this is, I probably didn't realize that maybe it might confuse some people, right? So lead is the struct that you've defined, right? It's the data type that you have defined, which is almost like var lead could be an int, could be a string, or could be a lead. Lead is your own data type here. So lead is the name of the variable, whereas lead is the data type, which in this case is lead itself, which is a struct. Okay. Now you want to say db.first lead, ID, and if lead.name is equal to none, we'll say c.status 500.send no lead found with ID, and we'll return from here. And
say db dot delete ampersand lead and c dot send lead successfully deleted. So we get the ID, right, using the same method that we did for get lead. Sorry, this lead here is actually capital L, right? So I hope you can see what the issue was. The issue was that there was a small L here that I didn't lead, but it'll always be capital L because that's how you've defined this lead struct. Okay, so delete lead, you got the ID using the same method that we did in get lead. You got the ID, right, from c.params. Then you have DB, which is the instance of the database connection. Then you define a lead of type lead struct, and then you find the first lead that you find with this ID. Now, if the name of that lead is nothing, which means that lead is not there, that means that no lead was found with that ID. But if that lead was found, then you'll just go ahead and delete it, and you'll say lead successfully deleted. That's about it. That's it. That's your lead.go file. And then there's only one thing we are left with. Okay. And this is the thing that sometimes throws people off. Mostly people who are coming from a JSON background or from a JavaScript background, is that JavaScript understands JSON by default, right? So whenever JavaScript developer goes to another programming language like Golang or Python or Java or anything else, Rust, Ruby, whatever, they get confused with this idea of that how can a language not understand JSON, right? It's because JSON is JavaScript object notation, and obviously only JavaScript understands it natively. But all other languages like Golang, we have to massage the data, the language to be able to understand JSON. So what you need to do out here is, with name, you'll have to say JSON name, and you'll say JSON company. So JSON email, JSON phone. What I have done is I have used these backticks, and inside that I've used set JSON, and I've used in double quotes name, company, email, phone number, like that. And what's happening here is that we're telling Golang that in JSON, this is what it's going to look like. So for your reference, hey Golang, for your reference, we are saying that it's name with capital N, company with capital C, email with capital E. But the JSON that you'll receive will be with small n, small c, small e, small b, right? This is how the JSON is going to look like. And we're expecting Golang to understand the JSON, right? So this is what I basically wanted to show you. And when you say, that c.json and in bracket leads, you're basically saying to Golang that, hey, whatever you received from the database, now you have to convert it back into JSON and send it to the postman or the terminal, whatever. Okay. So what I'm trying to say here is that Golang does not understand JSON, and it understands own structs, and it can only function or perform operations on that struct that it understands, and then it again has to convert something into JSON, and then only it can send it to the response, which we will understand, or our front end will understand. So this was basically your lead.go file, and database.go file is complete as well, and your main.go file is also complete. And I'm just checking just to see in case there are any issues. In my main file, I need GORM as well. So what I'll do is I'll just go ahead and I'll get the GORM, Fiber, and SQLite, all these three packages. I'll get into my Fiber I already have, so I'll remove that from here. I just needed these two packages here in my main.go file as well. Okay, So I think we are ready to be able to build this file now. So you want to, before you run this file, you want to build it. So what you'll do is you'll head back to your terminal and you'll say go build main.go. As soon as you build it, you see this file called just main. It's just called main. And what that means is that it's an executable file. It's a .exe file. It's executable, and like .exe, if it was Windows, it would be an .exe file. But whatever operating system you're using, it'll create an executable file for that operating system, so that you'll be able to run that program. And now all you have to do is go run main.go, and it'll run the program for you. As soon as you do that, you need to see these two things: connection open database. You have to see that. Database migrated. In case you don't see any of these, that means your program is not working properly and you need to check the code. I'll push the code to GitHub as well. So this means that our project is working. Like we see this nice fiber text here, and then you have your port 3000 on which it is working. So everything seems to be fine. You have 4 APIs, 4 handlers. Okay, so now all we have to do is go to our Postman, and this is the collection that I've created for my Go Fiber basic project. There's an add lead here, as you can see, right? So I'll create this I'll create this lead. So this had an ID. It has created at, updated at, deleted at, and then you have your name, company, email, phone. Now these 3 timestamps, right? Created, updated, deleted. These can be added automatically when you add some data, and these are optional right now. You don't have to add them, but you may have seen that in many programs it's added automatically, and I've shown how to do that using the time package in my other projects. Since this is beginner-friendly project, I have not used the time package. I've not shown you how to use those timestamps. Okay, and I'm sending it manually from the front end or from Postman. So here, I'll just change the ID. I'll create another record. I'll call this Alex Clinton. Let's call him Alex Clinton. We'll call the company name Microsoft, and email would be alex@microsoft.com. And we'll change his phone number a little bit. We'll send. And you can see that it's created another lead for us. If I want to get all leads, you can see that I'm on the same APIs that I have defined here, right? So if I go to my main.go file, API/v1/lead. So you come here, localhost 3000 and API/v1/lead. That's the API you're on. You send, and you can see we have created these 2 leads. So it's working perfectly. You created 2 leads, you can see those 2 leads. Now you want to get a particular lead, right? So you'll come here, and you will now look at the API, which is the get API for the particular ID. In the end, you want to add an ID, right? So in the end, I've added 2. When I do that, I get my Ramsey Peters. And if I add 1, I get my other guy. And if you want to delete a particular lead, it's the same, right? Same API, as in same route, but the method is delete. So you want to change your method here from here to delete, and you want to delete the lead too. So it says lead successfully deleted, and now when you check get all leads, it'll show you only 1 lead. Make sense? That means your entire project is working. This is your simple lead management system. This is a very simple beginner-friendly project. We'll be building an HRMS, which is a human resource management system, and we'll be using Golang, Go Fiber, and MongoDB. So essentially, you'll be learning how to use Go Fiber along with MongoDB, but in a format of a small project. So it's a very good way for a beginner to get their feet wet and applying what they've learned till now. Now, since this video is very beginner friendly, I won't even be having different files. I'll be having everything in the same file, main.go file. So we won't be learning about project structure here because it's again for complete beginners. But in case you want to see more complex project structures and design patterns and all that, I have a lot of projects already on my playlists. Without further delay, let's get started, and I'll just open up my terminal now. As you can see, I've opened up my terminal now. I'm using PowerShell on Windows for this project.
And it doesn't matter how you've set up your Go path or how you've installed Go. We'll be using Go mod, and that means that we can have the project anywhere, and Go mod will handle the dependencies for us. So I'll create a new directory for myself for this new project. I'll call it Go Fiber Mongo HRMS, and I'll cd into it, and I'll open up. So before I open up this on a VS Code or any other code editor, I'll go ahead and say go mod init, which initializes your mod file, and you'll give it an absolute path. You'll say github.com/akhil/ and the name of the project, Go Fiber Mongo HRMS. Okay, and now you can go ahead and open it up in a code window. I'm using VS Code. VS Code works out really well for Golang. So in case you're using something else, just try VS Code once. So as you can see, there's already a file called go.mod that exists for me, right? And it mentions my name of the project and also mentions the version of Golang that I'm using, so that if anybody else takes up this project, they can easily install all the external packages that I'll use using this file. And all the external packages that we'll install in our project, for example, the drivers that we'll use to work with MongoDB, you'll see them listed out here. So as I said, we'll have only one file in this project. And so main.go is the file, the most important file usually in a Golang project. And what you want to start off with is you want to say package main. And you'll want to import some things here, okay? And after importing those things that we'll talk about in a while, mostly around, the things that we'll import will be mostly packages around MongoDB. We also want to create a Mongo instance of a session with MongoDB so that we're able to interact with MongoDB. And it will be basically a struct. So Mongo instance, struct, and you'll have a client and you'll have a database. So a struct is basically your own data type. So you get some data types with Golang, like int, string, uint, all of those, float, and all of those different data types. But what if you wanted to create your own data type, right? You can do that in Golang using something called a struct, almost like an object with JavaScript. And so it'll have two different things. One is client, one is DB. And here we'll have to write some things, which I won't write as of now because we have not installed those packages. But to be able to work with this struct, I'll need a variable called Mongo instance. Now this is how you define variables in MongoDB, in Golang. You have this variable mg, and it's of type, this is the data type. So it could have been string, it could have been int, but right now for this, for what we're doing right now, it's Mongo instance. Mongo instance is our own data type that we've just created, right? It's a struct. It has a client, it has a database, okay? So I also want to define two constants. So the first constant will be the DB name of the database that I want to work with. DB name. And it's going to be called, let's say we call it Fiber HRMS. And you want to define a constant for Mongo URL. Now, in this video, I'm going to be using the local host MongoDB. That means that MongoDB is installed in my local computer. And it'll be running on a port. And MongoDB usually uses 27017 as the native port. Now, you could be using MongoDB on your local machine like I am using to keep things simple. But if you are using a fully managed service like MLab, they will give you a link to embed in your program. And that's the link that you'll put here in the MongoDB URI. Okay, so in my case, I'm using localhost. So this is how I'll write the link. So it'll be MongoDB. And after these two slashes, you'll put your own actual link that you got from your managed service. In my case, it's just localhost. And my port is 27017. The way you have configured up your MongoDB also makes a difference here, because you might have to write your username @ your password, and then the localhost. So in my case, the way I have configured my MongoDB, I have not kept any username or password for my admin user to as an connect directly with MongoDB without requiring any username or password. In case you don't know how to set it up like that, there is a video on how to install MongoDB. I think it's long. I put it up long back. So you'll just have to search a bit on my channel and you'll find it. It's very simple. It's very straightforward, right? You just set up MongoDB without any users or passwords. It's just easier to work like that, especially if you're building very simple projects, right? And here you want to add the DB name. The DB name is Fiber HRMS, and that's what will be added. So when your MongoDB gets connected, it'll get connected to 27017 and by default to this database called Fiber HRMS. Now comes an important part, which is basically how you'll define your employee. Now in human resource management system means it's a company and they have a database of their employees that work there. So the employee will be a struct. Now you can manage name as a string or salary as a string or as a number. But how do you manage all of that together for one employee, right? So that's why you create a struct, right? So there are these data types that Golang understands. Then there are these data types that you can create called structs that you can make Golang understand because they have these different fields. Like for example, there'll be a field called ID, field called ID, field called name, just name, and field called salary, field called age. And all of these fields will have a data type like string, for example. Name will be string, salary is float, and age is also float. Right, so now these fields like ID, name, salary, age, they're of data types string or int or float, whatever. So that means Golang can understand what we're trying to say, right? But all of those combined make up a struct. And since Golang understands those individual things like ID, name, salary, age, it will also understand this whole struct, right? Which is now a new data type that we've created for our use. Okay. Now, there'll also be something else that I'll add here, but not right now. And I'll explain to you what it is. But just keep this like this. Keep this as just a struct for now. Okay. Now you'll have a function for connection, which basically helps you to connect your Golang to MongoDB. So you'll have the connect function here. And every function basically takes in something and returns something. So error is what's returned by this function if things go wrong, and it takes in nothing basically. So there are these empty brackets, right? And inside this will be a function definition that we'll write in a while. And at the end will be funcmain. So funcmain is an important function usually in the main file. Funcmain is the most important function, and that's where the control of the program usually begins. Okay, and here you want to first define your app. Now if you've used Node.js by any chance, and if you used Express, because you have to use Express with Node.js, right, mostly. So if you've used Express, that then you know that you have to define the app variable in the beginning, which is basically an instance of Express, and that's how you interact with Express. And exactly that's what we're doing here, because Fiber is the equivalent of Express. So Express is with Node.js and Fiber is with Golang. It's an exact equivalent, but Fiber is like, I think they say it's 10x faster or something like that. It's really fast, basically. That's all I need to know. Okay. So now when I say fiber.new, that means I should have had the Fiber package. So this is how you install or, in the import statement. This is how you import an external package. So you say go fiber slash v2. Sorry, it's a small v, okay? So it's a small v2. And
you also want to get some MongoDB related packages. But for now, let's just keep it this much. And what we'll do is we'll go over to our terminal. And whenever you import a new package, right, you have to say go mod tidy, so that Golang will go online and find the model package for you and will install it in your program. Now, after your Fiber definition, you want to have the standard functions, so which are also your routes, right? So the first route that you want to define is /employee, and this is the get route. Then the first route with the get method is going to help you get the list of all the employees that are there in your database. Then you want to have a post route, and then you want to have a put route and a delete route. Okay. And for post route, the route will be the same. For put, there will be just an ID after employee. For delete also, there will be an ID. And the way you start off a function is basically when something lands on this route or somebody calls this route, you want a function to get called. And that function basically can return an error if something goes wrong. And it'll have a definition, right? The function will have a definition. The function usually takes C, which gives you fiber.context. C, which basically is type of Fiber, which you get access to from here, from the library Fiber.context. Now, there's something really important here for you to understand, is that whenever you have a function like this, like a route function, you want the request, you want to be working with request, and you want to have the ability to send out a response, a JSON response. By request, you mean whenever the user sends, let's say from his Postman or from curl, whatever the user sends to the program. And it could be an ID, it could be like in case of the post request where you want to add a new employee, it will be the new employee data, right? And the data for the new employee. So that will all come in the request. So you need the ability to work with that request, and you want to be able to process that. So like, let's say you added a new employee, or you deleted an employee using the ID, or you updated an employee using the ID. And you need the ability to also send out a response back to Postman or to the terminal. So both of this can be done using Fiber.context. And C is how you're going to be accessing the response and request. Okay. So this is what was important for you to understand. Now, before you start with all this, right, you also need to be able to connect with a database. So you'll call the connect function here. And connect function is exactly the same function which you're going to define out here. So what's happening here is you'll have if error, you'll handle the error here itself, and if error not equal to nil, then you'll log.fatal error. So the log library helps you to log out errors, and we have not imported it here, so we have to import the log library here, right here like this. All right. And what we want to do now is we want to start creating our connect function. So come over to your connect function, and we'll say mongo.new client. Basically, you want to create a new client for MongoDB. Now, this word Mongo basically comes from the Mongo library that we have not installed or imported yet. So let's go ahead and get the MongoDB libraries. The first one is go.mongodb.org/mongo driver/pson. So firstly, just get Mongo, just get Mongo, right? And the spelling here is wrong. So just make sure you write the right spelling, which is Mongo is MONGO and driver.
Okay, so that's the main important library. Now this library has a few more things that you can get, right? So the first thing that you can get are the options. So you'll say go.mongodb.org/mongo/mongo, and then you'll get some options. And then Mongo has some BSON and primitive that helps you to create that ID, right? So we'll have to import that as well. So you'll say go.mongodb.org/mongo driver/bson. This will help us to create the ID for every single record. It will be a BSON ID. And we'll have again mongodb.org/mongo driver/bson/primitive. Now, if in case you're worrying that you'll have to remember these 4 links, you don't have to. You just use it once here. And every time you now connect with MongoDB, you just have to copy those 4 links. I didn't copy them. I could have copied them. And any other tutorials you'll see online, they will copy them. I'm just showing it to you, so that you understand that you go to go.mongodb.org website. Then you go to the MongoDB, which is the main Mongo driver, which is like the main parent library. Then you have like Mongo, which is the package, the ORM that you use, and then you have your options. Then you also have your BSON and primitive. Okay, so that's why I just wrote it for you to see that they're all linked and all related, so that you're not just blindly copying all of that. Okay, but mostly from now on, once you've done this project, you just have to copy and paste these 4 lines everywhere. So what happened is when I just pressed Control S to save it, there are some plugins or extensions that I'm using for Golang that basically recognize that I'm not using those packages right now. So they have removed those packages for me. So I'll Control Z and not save it as of now. If I try and save it, it'll remove those packages that I'm not using. So it basically helps with error solving. And you can also go to your, your extensions. And you can just write Golang, and the first 3-4 packages that come, you can just install them. They just make development a little easier. Now that we have installed or imported these packages, now it's going to be very easy for us to work with our connect function. Okay. So you say mongo.new client, and then you say options.client.apply URI. So this function, right, options.client.apply URI, you already get from the Mongo package that we're using. And apply URI is a function where in that function you pass basically your Mongo URI that you've just created. So all it's doing is it's going to apply that URI and basically going to connect and create a new client for you and for that URI that you've just created or just given to this program. And you'll get access to this whole thing as in the complete connection instance using the client, right? So whenever you want to work with client, you don't want to keep writing this all the time, right? You want to be able to, you want to get all of that in one variable that you can use later on. So that's what the client is in this case. And in case you don't know what this is the walrus character. This basically, defines a variable and also declares and defines at the same time. So here you also want to have something called as a timeout. Now there are some functions with MongoDB that are blocking functions like insert, right? And you don't want it to block the entire program. So you want to always have a timeout. And timeout basically with this MongoDB package for specifically, it uses the context package that already Mongo has to give you this ability to define timeouts. So this is how we define timeout. So you'll say context dot with timeout. So in case your MongoDB is not responding or something goes wrong or the insert is taking too long, you have a timeout. You don't want to block the entire program. And now this is not compulsory, but this is a good practice. I mean, you have to. It's not like without writing this, the program won't work. It will work without it, completely fine. But I recommend always writing this down. Okay. So you'll say backgrounds, comma, and you can give any time here. You can give a time of 10 or 20 or 30. Now, what you'll notice here is that time, as soon as you write time, it's not recognized by Golang. That's because Golang is so modular that Golang doesn't even have the ability to print things, or even the time package is even the time ability to understand time is also not inherently available inside Golang. So this basically makes Golang very lightweight and very fast. Okay, that means that time is not understood by Golang. That means it's a different package altogether. So you'll have to come up here and you'll have to install time package on your own. Now, the extensions that I'm using were able to get the context package for me automatically. So when I used context out here, even context is not understood by Golang, but somehow the extension decided to get the context package for me automatically. I didn't have to do it. Anyhow, there's a squiggly line here that means context. There's no function called with timeout, and that's because the O should have been small. And now Golang starts understanding it very quickly. You get a squiggly line here with client and error. That's because you've defined these and you've not used these as of now. And Golang has a problem with that. So in case you define something and you don't use it, Golang has a big problem. So we'll quickly, we'll use it. We'll basically use these two variables. Okay. Now, you want to run this cancel script at the end of this program, and that's why you use defer. And now you want to say client.connect, and you want to pass this context here. So here, I forgot to show you that CTX and cancel are the two things that you'll get here, right? So when you say Control C, whenever you run your program, right, in the terminal, and you say Control C, it'll basically cancel this. It'll have that timeout here. Directly, it'll just cancel the entire operation, whatever is running out there. So now you have client.context CTX. The context is what you will pass here to be able to connect to the database with the right context. And you will again get that in the error. If there's an error there, you'll get that in this error variable that you'll handle now. And you'll also have a variable called DB. So we'll say client.database, and you'll pass the DB name here. So you've connected to the database, to the MongoDB, but you also want to connect to the right database, right? And this is how you do it. And you'll be able to use this now, the database, using this DB variable. So this error that we've received, that we may have received if things went wrong while connecting or while creating this new client, those errors we'll handle right now. So we'll say if error not equal to nil. And by the way, this is a common theme with Golang, that always when you write something and then you might expect an error there, you'll always handle that error just there itself. So here we'll handle the error, and we'll have return error. Now you might remember that we had created our MG here, right? Our instance MG. And here we'll say MG is equal to Mongo instance. Then you'll have client, comma, DB. And you'll return nil from this function. Okay, so you've created your MG, which is your Mongo instance, which is of type struct, and the values here for the client and database, right, have now been set. So this is what we did here, in case you didn't understand, is that for the client, it comprises of two things. Remember, struct is basically your own data type, and in this case, it's Mongo instance, which is a struct, and it has two things. One is the client, the other is the database. So client means the client MongoDB, and database means the database name that you want to connect with. And that's why we created this DB, and that's why we created the client, these two variables here, so that we're able to define our own struct, complete struct. And MG is basically what we'll be using to further on if we want to work with the database. So that's what your instance consists of. Now here, you want to say that client is of type mongo.client, and DB is of type mongo.database.
Make sense? Right? Now, I know I said I won't use pointers, and this star is basically a pointer. So what we're saying is that it's a reference to mongo.client and mongo.database. If you don't understand pointers right now, it's not a problem. You don't have to really worry about it. I'll have really basic videos coming up on what pointers are and how they work and why they're used. For now here, this is the only place where we're using it. So, and also the other place where we're passing a pointer to the fiber.context. So you just have to remember that you have to put stars in front of these for now. And we're just passing these by reference. About pointers, I'll create like a 20-30 minute video just explaining pointers. So don't worry about this right now, okay? And there's no advanced pointers getting used here. It's just for this part, so don't worry. Anyhow, now coming to your employee struct. Now there's something that I want to do here. And I think right now is the right time to do that before we start creating all these handler functions for our routes. So one important thing that I want you to understand is that Golang does not understand JSON natively on its own. Just like if you're coming from a JavaScript background, you might feel that JSON is basically understood by all languages, and JavaScript people have this confusion because they feel that JavaScript understands Golang JSON, so that means all languages will understand JSON. But it's not like that. It's because JSON is JavaScript object notation, so only JavaScript understands it natively. All other languages have to use some packages to be able to understand it. In our case, we have to use a package called JSON. We have to do a lot of encoding, encoding and marshalling basically for understanding and working with JSON. And but in this case, since we're using Fiber takes care of a lot of things for us automatically by default. And it's all happening under the surface, like a lot of marshalling is happening under the surface. So Fiber makes things very easy for us. But otherwise, by default, Golang does not understand JSON, right? So that's why whenever you define a struct, and the struct is going to actually represent the data in the database in your MongoDB, which understands JSON, by the way, it's a JavaScript database. And the data that you're going to get from the user as a request is also going to be JSON, right? So when data comes from the user as a request to Golang, it does not understand it because it's JSON. And when data comes from the other way, from the MongoDB to Golang, and then Golang has to send it to the user, again, Golang does not understand it because it's coming as JSON. So this is why you have to tell Golang that, hey, you understand ID as string, and this is what it's going to look like to you, right? ID is going to be string and name is going to be string. But in JSON, it's going to look a little different. So we just have to help Golang here. And we have to say in JSON, it's going to look like this, man. ID, and we'll also write omit empty for ID. And as you may have worked with Golang, with the MongoDB, it also needs bson for the ID. And this is how it represents ID at the database level. ID, comma, omit. Now, I'll show you name also, and then I'll explain the difference here. Okay. So what's happening here is name is understood by Postman, is understood by your terminal when you or by the user when you send a curl request, right? Name is understood as in JSON as name with small n, whereas Golang understands it as name with capital N, and for Golang it's a string, right? But when it comes to ID, the Postman understands it as JSON ID, whereas MongoDB stores it as bson, which is underscore ID. So this is why we have written bson again, right? For MongoDB. I hope that's understood. And then you have your salary, which is again JSON, and your age, which is age in JSON, right? So all of these fields, they have small n, small s, small a. Whereas for Golang to understand and Golang to work with this information, it'll be capital N, capital S, capital A. So now we want to start working with our main functions, the main handler functions like get and post, put, delete, all of these functions, right? The route handlers. So we'll start with get. That means we want to get all the employees from our database. To do that, you need, like I told you, Golang does not understand JSON.
right? And you'll get something from the database. Golang needs to understand it, and Golang needs to send a JSON response to the front end or to Postman. Now, to be able to work with that, I need a variable called employees, and it's of type employee, right? So this is how you define a variable. You say this is the variable name, this is the type, and you see these two brackets here. That means it's a slice. So it's okay if you don't know what slice is. Slice is basically like an array, but instead of containing just numbers, it contains actual objects. By objects, you mean basically all of the things, the multiple things that this array will contain will be an actual employee, the whole employee, right? So this means that if you're coming from a JavaScript background, this would mean that it's an array of multiple objects. So now you initialize it using the make command and employee 0. So you've defined your employee variable, right? This will help you to work with the records that are fetched by the database, from the database. Now, to get something from the database, you have to use the find command that MongoDB already has, right? So the find command, you usually send a query. In our case, since we want all the employees from the database, that means the query that we have to send is completely empty, or just two empty brackets. Okay, so we'll have to define the query here. So query is equal to json.t. And inside these two curly braces, you'll define the query usually. In our case, the query, like I said, are just two empty brackets because it's an empty query. So this is the query basically. So we've defined the query. Now, you want to use the find function that MongoDB will give you. And inside that find, you'll pass query, right? The query that you've defined here. But you'll also pass the context. Right? So you'll pass e.context and you'll pass query here. So I hope that's making sense. Now, this find function is available to you inside MongoDB. You know that already. And how are we talking to MongoDB in our program? We're talking to it using the MongoDB instance that we've defined here, right? The Mongo instance. And the Mongo instance has something called as DB. So we want to target that Mongo instance, and we want to talk to the database, exact database. Inside that, we want to talk to a collection. Collection is like a table. So with MongoDB, you have collections, and with an SQL database like Postgres or MySQL, you will have tables. So if you're familiar with tables, it's the same thing. It's just a collection. So you want to go to that instance, you want to go to the database, and you want to go to the collection, and then you want to basically run the find command. That means you'll go to the instance mg dot, you'll get the database inside mg, right? So it's mg, and this database you've already defined the variable there already. It's already set. And dot, you want to get the collection. So the collection, so it's C capital, and everything else is small. Collection is employees, and you'll say dot find, and you'll find the query. And here, what you get back is usually the cursor. Basically, it'll have all the employees records, or you'll get back the error. So now you want to handle the error. So you'll say if error not equal to nil, and for the error you want to return a status of 500, which is basically your internal server error. You want to send a string, which is your error string. Basically, you're sending the entire error itself. You've defined your employees already here. Okay, one small mistake that I see here that I've made is that this bracket is not here. It's actually here, the close bracket, because it's a slice, right? Employee is a slice. This is how you define a slice. Those two brackets and then employee. All right. Now, what you'll do is you'll use this cursor. And here also I see one small mistake is that D is going to be capital, B will be small, and now Golang will understand it. So that's why the squiggly line quickly goes away. All right. So now what you want to do is you want to say cursor dot all C dot context, comma, ampersand employees. When I say ampersand employees, I'm basically passing a reference to this variable employees that I have sent.
And what's happening here really is basically whatever data we've received in our cursor, right? And from this function that you've run here, cursor, which is all the data of all the employees from the backend that has been received. This is going to basically convert that into a format, into the structs that are understandable by Golang. So that's why you pass these employees, right? So in the end, you'll get employees, right? But that will be basically a slice of multiple different employees. And we did this because Golang cannot understand JSON, which MongoDB understands. And when MongoDB sends it some data from by running that find function, you now need to convert it into something that Golang understands, right? And this is how you've done it. So you'll say if error is equal to, sorry, in front of this you want to say if error is equal to, and error is not equal to nil, and you want to return c dot status 500 dot send string error dot error, right? And here you want to return, if everything goes well, you want to return the employees that you just now converted. Employees was that variable that you defined, which was a slice of employee, right? That means multiple employees will be there. And that basically is what you got from the database. You converted it into nice, understandable format. And in JSON, you sent it in JSON to as a response to the front end. Okay, so I hope all of that makes sense. Now we'll move towards our post function. So we'll make some space here for post function. We'll have our func, and similarly, this function will also accept a pointer to fiber.ctx, which gives us access to our response and request. This is how we're able to use response and request. And it also does a little bit of marshalling and marshalling for us. Like here we did c.json, so it can do some marshalling and marshalling for you by default. It does take a lot of work away from you and gives you some abstraction. So here you want to define your collection. So we'll say collection is mongodb.database.collection and employees. So instead of saying this again and again, mgb.db.collection.employees, I've defined it and I can now use it in a variable called collection. And I'll create an employee. Now, when creating something in a database, right, you have to use the insert function that MongoDB will give you. And also you'll get just one employee, that one employee data that you're getting from the postman, that as in the user will send the data of a new employee. And that new employee, right, variable is going to basically go to the database. And this is how we'll define that employee variable is equal to new employee. So when we say this, right, you can define it like this, or you can say var employee and employee. You can say like that, or you can say employee is equal to new employee. All that's doing is that it's defining a variable called employee, which is of type employee, the employee struct that you've already defined, which has ID, name, salary, and age. Right? So now you have defined your employee as well. And what you'll do now is you'll get some data in the request. You'll get the data of an actual employee, as in the user wants to add a new employee, right? So you'll send a new employee data like name and all those different things, name and salary and age to this API. And this API needs to now read that information. And it does that using C, which is basically your fiber context, dot body parser. So you'll say body parser. And when you say employee here, that means all that data basically becomes formatted in the format that you need, and you get it into this variable called employee, right? So it basically parses the body, which is in JSON. You're sending from JSON into from Postman into this Golang program, into struct that Golang now understands. And after you've done that, you want to handle the error. So you'll say if error is equal to c dot body parser employee, and if error is not equal to nil, there can't be any space between exclamation mark and is equal to. And here you'll return c dot status 400 dot send string error dot error. Okay. Now we always want MongoDB to create its own IDs. And this is why what we'll do in the beginning is we'll say employee.id equals 0. This forces MongoDB to create its own ID. And now I want to take this collection that I've defined here. So it's good that I defined it as a variable because I can now keep using it. I don't have to always write this again and again. So I'll say collection dot insert one. Now insert one is a function that I get with MongoDB. So if you're familiar with MongoDB and the functions that you get with MongoDB, it's really easy to understand. You can insert one. Insert one basically takes data and inserts that into your database, just one data. Into that insert one function, you will pass c dot context, comma, employee. So you received some data in the body. You used body parser to convert that into employee, which is your employee struct, and that employee struct basically is what you're sending to the insert one function along with the context. And whatever I get back from this function after inserting, right, I'll keep that in a variable called insertion result. And also an error. So if the error is there, then I'll handle the error. If error is not equal to nil, that is, it returns c dot status 500 dot send string error dot error. The spelling of return is wrong. Now after it gets inserted, it'll come in this variable called insertion result, or you'll get an error. And this error, we'll handle it right now itself. And we want to do something with this insertion result. What we want to do is we want to get the ID from this insertion result that you get, right? Then this ID, we'll use that to search the actual record that has just been inserted in the database. And then after finding that record, we want to return that to the front end, okay? And this makes us doubly sure that whatever we did the post request for right now, it was inserted in the database. And we can make that sure by actually going and searching for that record using the ID and then sending that record. And this makes it very sure that this data was actually inserted in the database. Make sure? Yeah, makes sense. All right, so here first I'll handle the error, okay, quickly. So if error is not equal to nil, I'll give some space here. Then you want to do something. You want to return c dot status 500 dot send string and error dot error. All right. Now, like I said, we want to take the insertion result, which is insertion result, and we want to get we want its ID, right? So we want the inserted ID. And using this ID, we'll create a query and then we'll find the record that has this ID to check if what we just inserted right now using insert one was actually inserted in the database or not. Okay. And so let's say value is equal to insertion result or inserted ID. And basically we're building up a query, right? So the key is ID, and for that key, which is ID, the value is this inserted ID that you just received. Enclose it with inside another pair of curly brackets. And say filter is equal to JSON.d. Just like you had created a query here for get, which was bson.d, and the query was empty, right? Now you have bson.d. It's called filter, not filler, filter. And bson.d, then the query has key, which is ID, and the value of ID is basically insertion result that you just received right now, and the inserted ID of that. And you want to get the created record that we just created. How do you get it? You use collection dot find one, and you pass c dot context to it, and you pass this filter query that you just created. You pass it there, and that's how you get the created record. So I'll repeat again. You inserted the employee data that we just sent using Postman, the complete employee data, and you used insert one query to insert that data of employee. And you got that, whatever you got back from this function was stored in insertion result. And that insertion result also has a variable called inserted ID, which basically has the ID of the data that just got inserted. And you keep that, to build a query, and you keep that in this variable called filter. And this filter is basically what you send to find one function. And we're just rechecking that this data was created. And then you get that into this variable called created record. So this is the record that was just created right now by you. And this is what you want to send to the front end. So you will create a variable called created employee. Now you want to structure and format that data, right? So you say that created employee is a variable of type employee, which is your own struct, right? So created employee will have ID, name, salary, age, type employee. And you want to say created record dot decode, and you want to decode the created employee. Okay, we are doing this decoding because, as you know, Golang does not understand JSON. So we have decoded that into a created employee, right? The whole JSON that we just received from MongoDB. And now you want to send that JSON as response to the front end. So you'll say return c.status 201 dot JSON. By the way, 200, 201, 203, 400, 500, these are standard statuses, HTTP statuses. You can read more about them in case you don't know which status is used when. So you'll send the created employee. Make sense? Now, I've actually used insertion result here. So let me make sure if this is the same spelling I've used here. Yes, the same spelling. Now, a lot of these packages have these squiggly lines. So what I need to do, obviously, is I need to say go mod tidy, so it gets all those MongoDB and MongoDriver options, since I've not done that for quite some time now. And if I go ahead and save it, it removes one package. I don't know which package it would remove. Anyhow, let it be actually. So yeah, just save it actually for now. And you can see that all the issues have gone away, right? We don't have any issues now. Now we want to work on our put function, but let me first check if everything looks fine with the post function and if there's no big thing that we're missing as of now. Yeah, everything seems to be all right. So now we want to work on our put function. Put is basically your update. And then you have, at the end, you have delete. So I'll just create some space here just for some, clarity. And here, as soon as somebody hits this route, you want to call a function. You want to call a function, and this function is going to take C, which is of type fiber.cdx, returns an error. Yeah. Now the thing with IDs is that you get them very easily. You can access them really easily using the C, which is the context, C dot params. So the params will have the parameter, which is ID that you've just passed. And I'll capture this in a variable called ID param. And also, I will create it from hex. So I'll say primitive, the primitive package that we're using, say object ID from hex ID param, and I'll store that in employee ID variable, or we'll get an error. So either it'll get converted or we'll get an error. So it's giving us squiggly line for primitive. That means, yeah, so that means when I saved it last time, it had removed the primitive package here. So I'll copy this, paste it here, and I'll say slash primitive. All right. It's showing me 3 issues in the file. I know there are 2 issues from here because these 2 we have defined, but we have not yet used. Anyhow, so now we'll go forward. We'll handle this error that we might receive here. So if error is not equal to nil, we want to return c dot send status 400. Okay. And just like you did with post, right? So update APIs are usually very similar to the post APIs. So just like you defined a variable called employee and it was of type struct, which is employee struct. Similarly, we'll have it here, right? And similarly, the data you need to get from the body parser and you want to get it into this variable called employee. So very similar. So you will define a variable called employee is of type employee, and you can define a variable like I said, var employee, or you can just say employee is equal to new employee. 2 ways to define a variable in Golang. Many more, but these 2 are the most widely used. So here you'll say c dot body parser and employee, just like you did in the post API, and you'll handle the error here. So error, not 3 R's, just 2 R's. If error is equal to this, then error is not equal to nil. Then it will return c dot status 400 dot send string err dot error. Now we're going to start building up the query. Okay. So because why do we want to build up the query? Because the ID that we've just received in this API, right, from the request, for that ID we need to find the exact record in the database, and then with this new data that we've received to update, we want to update or replace that data with this new data. Make sense? So first we need to find the data for that ID. How do you do that? You create a query, you say bson.d, and you'll say key is underscore ID, comma, value is employee ID that you just defined out here. Okay. Then you'll say bson.d, and now what you want to do is you want to build the update query. How do you build the update query? You want to have, so when you do an update query, right, you have to have $set, as in set this new data for instead of the old data. So in case you already are familiar with MongoDB, it will be very easy for you to understand. If you're new to MongoDB, just remember that with $set is the operator that you have to use inside MongoDB to set this data for the data that you are replacing. So this is how it's going to look like. It's going to be bson.d. Inside that you'll have a key, and the key will be $set like I just mentioned, comma. There'll be a value for that, and the value is defined like this. It's bson.d. Inside that you have 3 things. You have 3 things inside here. 3 things because there are 3 fields to it. One is the name, comma, value employee dot name, and here you'll have key age, comma, value and employee dot age. Then you have key salary, comma, value employee dot salary. Make sense? Here you'll just put a comma here, and then here also you put a comma. So now that we've built this query, you wanna capture this in this variable called update. And now you can see all the squiggly lines went away quickly. And you want to write the update function. So the update function that you get with MongoDB is called find one and update. So you'll say find one and update. You pass c.context in it. You pass the query. And when I say query, I mean this query that I just created with the ID. So you find that variable with the ID. And the update basically is the query where you set the new data for that particular ID, right? So you pass query and you pass update, both of these things. You say dot ERR here. And where do you want to run this? You want to run this very similar to what you've done before, right? You want to run this query in the Mongo instance like this, the instance that you have, right? The Mongo instance, which is mg dot database dot collection, just like you did here with your app.get, right? So the same thing you want to write here. You want to say mg dot db dot collection, and inside that collection you'll say employees, right? And error is equal to all of this. Now you can handle the error. So guys, I just need some energy drink because I'm getting a little, like, it's a long video. If you don't mind. All right. So if error is not equal to nil, that means that the filter did not match any documents. So you want to say if error is equal to mongo dot error no documents, right? So there's an error, and an error is that MongoDB does not have those documents. Then you're going to return c dot send status 400. So 400 status, you mean it's for not found. That means whatever ID that you're trying to find and replace the data for, it does not even exist. So there's something wrong. So that's what you do. Otherwise, if there's a regular normal error, then you just want to return 500. All right. And you want to set the employee ID. So you'll say employee dot ID is equal to ID param. And if everything has gone well, you want to send 200, saying everything is okay. You want to send the employee. So we'll say return c dot status 200 dot JSON and employee. Cool. Now the only function that we're left with is the app.delete function. But you may have realized that till now we have not actually started our server, right? We've not written anything to start our server. So to start our server, we'll just have to do just this app.listen on port 3000. And if there's an error, you want to enclose this whole thing and you want to say log.fiddle. So if the server does not start due to some issue, like the port is already taken or there's some other issue, we'll just basically be able to log out that fiddle error. Now you want to start building the delete function. The process is very similar. You want to, as soon as somebody hits this route or API, you want to call this function, which accepts C. You'll have fiber.ctx, and it returns an error. Inside that, you'll have, now you obviously want access to the ID, right, which is inside params. So you'll say c.params. Inside that, you have your ID. And you want to enclose this whole thing
into object ID from hex, and you'd say primitive dot. So instead of doing those two steps that we did earlier, like primitive dot object ID from hex ID param, and then doing this, we have done both of those things in just one step. So if I did this earlier in one step, you would have been confused. So this is why I showed you how to do it in two steps, and now how you can do it in actually just one step. And you get access to employee ID directly. This means you don't have to do all this part with ID param and then employee ID, right? You directly got access to the employee ID. Anyhow, now you can handle this error. So you'll say if error is not equal to nil, you'll return c dot send status 400. That means that probably the ID that you got here is not valid. So that's why you'll say it's not found 400. Now, what you want to do is you want to find the record with that ID and you want to delete that record. Okay, how do you do that? You'll first have to always, like you've been doing till now, you have to build a query because MongoDB understands queries. And the queries are in PSON format. And this is what the query looks like. It has a key, and this key, we're going to pass the ID, has a value. And the value is employee ID. Okay, so it has a key and a value. And I've put a double quote here by mistake, so that's why everything looks off. And now it's kind of fixed. And now I want to do the same thing. I want to call the delete one function. But wait, how do I get access to the delete function? I'll have to access the Mongo instance. I'll have to access the database. I'll have to access my collection. The collection is called employees. And inside delete one, you're going to pass context, comma, ampersand query. Just make sure the spelling of context is correct. And whatever you get back from this, right, from running this query, whatever you get back, you store in result, or you get back an error. And you can handle the error now. If error is not equal to nil, then you return status internal server error. So let's say return c.send status 500. And if the result is dot deleted, count is less than 1. So that means if it didn't get deleted, then you want to return c dot send status 404 not found. Yeah, so you want to say that it's basically not found. Okay, if nothing got deleted, if the deleted count is less than 1, so obviously that means there was no record like that. I think earlier by mistake I said, did I say somewhere that 400 is not found? Sorry, my bad. It's actually 404 that's not found. I got confused. 400 is your other type of server error. All right. And here now, if the record gets deleted, so you want to say c.status 200.json record deleted. Okay. And that's your entire delete function. So in about 168, 169 lines, you were able to write the entire program. Things look good to me, and now I think we should start testing it out and start seeing if everything works all right. So what you want to do now is you want to head over to your terminal. Not this one, sorry. this one. And you want to say go build main.go. Now what happens is, you see this main.exe file, right? So since I'm using Windows, it creates a .exe file for me, which is an executable file, and that's what build does. It creates a builds a exe file for you. And what you want to do is, you want to now run this program. So you say go run main.go. Let's see if it works. Okay, so we get some issue here. So let's try and fixing it. So we've received this error, right? And what do you make of this? It says there's something to do with Mongo driver, MongoDB client, right? So it's quite apparent that something has gone wrong with Mongo. And if I go to my code and I see that the drivers look fine to me, and I know the code that I've written is quite all right. And the only mistake that I see right now is with Mongo, obviously, is that I've not put a slash here at the end. And maybe when it's trying to add this with the database name, the whole thing is kind of failing. Maybe, right? That's my hypothesis. Then I save it and I run it again. And I'll have to build it, obviously, first. And then I'll run it again. If you don't build it, sometimes it runs the old executable file, so just build it. And now I can see that it's running the program. So that was the mistake, right? So with Golang, you don't have to be a genius to solve errors. So that's why I am very comfortable writing a lot of code and not testing it again and again. With other languages, right, you have seen other like instructors, they have to keep showing you how, just build a small part of the code and then they test and check it out if it's working or not. With Golang, you don't have to do it. Just write everything all at once, and then easily you can debug it. You don't have to be a genius, because it'll tell you the exact issue where the issue is, right? Anyhow, so it says Fiber is working on port 3000. There are 5 handlers, processes is 1, PID is 21308. All right, so now you head over to your Postman and you come here. I've created a set of collections, so get all employees, which is basically localhost 3000/employee. And I get all the employees that I have. And right now it's saying that I have 0 employees, right? It's an empty array. Obviously, we have no employees. That means I'll start creating employees. So firstly, I'll create an employee called Akhil. That's created. So it's created it for me. And I'll create another employee called Rupert. Now I see that there's another issue. There's a duplicate key error issue. Okay, so this means there's something wrong happening with our ID. And I kind of suspected that when I was creating Akhil, it didn't show me an ID. That means there was something wrong there as well. So now let me try and fix this ID issue. Back in our code, in the post function, everything looks all right to me. That means there could be some issue here. Yes, now I see the issue. There's just one small space between ID and Amit, empty. So let's remove that. And now I think it'll work, because this format that I had gone for, it probably MongoDB did not understand it. So let's cancel our process, build main.go and run main.go. And now I'll allow access on my firewall. And so let's try adding some employees. Let's try adding Robert. Cool, you get an ID here now. And you add Alex. Right, so you're getting these IDs here. You get all employees, and you'll see so many employees, right? Now what you want to do is you want to edit an employee. So let's edit Rupert. So I'll take this ID, go to edit employee. Just see that it's localhost 3000/employee/ the ID of the employee. So the ID of the employee is what I want to replace. And I can send any data here that I want. I'll change his name to Peter. And when I do that, Rupert's name has been changed to Peter. So if I get all employees, that second Rupert
has become Peter, but this first and third Rupert are always still there, but the second Rupert has now become Peter. Okay. You want to delete an employee now, so you just copy and paste his ID again for delete employee. When you paste it here, send, record deleted. Now when you get all employees, you'll see that Peter is not there. So the first Rupert is there, second Rupert is there, and Peter can't be found. So you can see that, right, the issue we were having earlier was that ID was not being generated for the first record. And if I was trying to add more records, it was saying that that same ID already exists. So it's an error for MongoDB. But now the IDs are being generated because I removed that small space. So all the APIs are working perfectly. Here's your little human resource management system. You can create employees, delete and update employees. You've learned how to work with GoFiber, which is a very nice library. You've learned how to connect a program which uses GoFiber with MongoDB.